Hi guys, and welcome to Magic. In this little magic trick I'm going to show you the equivalent of effectively a blockchain for HTTP REST invocations. First of all, you're going to need version 8.4.5 of Magic. There's a link in the description of this YouTube video to where you can download Magic. Secondly, I'm going to assume that you're capable of getting it up running, and for reasons of clarity, I'm going to assume that you're capable of actually dropping your existing Magic database. Why? Because there's a couple of new database tables you're going to need in order to actually be capable of following this tutorial. So this assumes you're starting out with an empty Magic installation. Login with username root/root. Then select the authentication database type. I'm going to be selecting MySQL, and then I'm going to be saving. This sets up your authentication database and a lot of other helper tables that you are going to be needing through this tutorial. Then click the Cryptographically menu item here, choose your Magic database, select all tables and click Cryptographically all. And it's now creating all the tables you actually need in order to be capable of fulfilling or following this tutorial. Then click the crypto menu item, select your key strength, provide a manual seed, and click generate key pair. You should probably not choose 2048, but probably something stronger for a production type of environment. But I wouldn't recommend you using this in production yet. It's an experimental feature. Have to warn you about that. Now we are going to befriend ourselves. Normally you wouldn't want to befriend yourself, but you would probably want to befriend another server, effectively, or a client. Effectively allowing another client to become a friend in your server. However, because I'm going to be loopbacking over localhost back to myself here, I'm going to befriend myself. So I'm going to copy this public key, which is my server's public RSA key. Then I'm going to go down here to public client keys in your system. I'm going to click import, paste in the key, and at this point it automatically determines the fingerprint for my key. Then I'm going to type my name, Thomas Hansen II, domain localhost :55247. Localhost :555-247. If you want to loop back, then just type some email address. Now here I want to effectively associate this particular public key with a bunch of functions or slots, which they are referred to internally in Magic. I'm just going to use the default here, except I'm going to do log.info and add that to. Then I'm going to click OK. And this happens to be, if you've seen my previous video, you know by now that this is the vocabulary that this particular RSA key is legally allowed to invoke on this particular server. Okay, so I now have befriended that public key, which happens to be my own, but it's quite irrelevant. It could have been a completely different one. And then I'm going to go into my evaluator here. Then I'm going to load the snippets, filter by Magic. Then I'm going to choose magic.crypto.hd.eval.idempotent. It's not entirely idempotent for that record. However, it's a similar type of ID, and you'll understand quite rapidly why it is. Now here I have a request ID. This has to be a unique ID on a per request level. Typically you'd decorate this using randomly generated QID or UUID or whatever, but any string would actually suffice. And then here I happen to just invoke log.info with the string of hello from YouTube. Okay, then I can choose to return something. Thomas Hansen was here, right? And when I invoke this, something extremely interesting happens. First of all, you see it resulted in a success status code of 200. Here is the HTTP headers, and here is the return value. And actually the return value was the invocation to the return slot here, allowing me as a client to decide what the server returns. In addition to that, I'm also capable of deciding what slots the server actually invokes. However, more importantly, if you have followed my previous video, this should probably be all news to you, except for one thing. If you now click the crypto menu item here, there's a log of this invocation. Here I can see my request that occurred 42 seconds ago. Here is the exact date and time of when it happened. Here is its request ID, and here is the key. If I click the key, I get to this public key, which of course is the public key associated with the private key that was used to cryptographically sign the entirety of the payload as I was invoking the server. I can also click, if I click on credit or request ID here, watch carefully here on the payload. This is the cryptographically signed payload, effectively becoming a receipt and a cryptographic guarantee that this particular payload originated from the person who owns the private key associated with this public key. So I now have a legal guarantee, and it's actually, yes, it is a legal guarantee according to laws in all civilized countries. If you have an invocation that is cryptographically signed with a private key that some particular user happens to own, then it is a legal and a cryptographic guarantee of that this request originated from the person owning the private key associated with this public key. And here is the code he sent me. And here is what we returned to the client. And of course you can filter by clients if you wish. And you can page back and forth, etc., etc. So what are the use cases here? Well, imagine that this piece of code here could be anything, including pay from the client's bank account, right? For instance, or buy photo if you happen to own image, photo, website, or whatever. At which point the client is allowed to download the image, yada yada, etc., etc. However, the big idea here is that I have a cryptographic guarantee of that this particular client sent me this particular payload, and in fact I can manually, if I want to, localhost /evaluator, I can actually verify that it originated sig signs. Okay, let's paste in that one. Let's go here. Let's find the guy's public key. Let's do key colon, and then I can do crypto dot verify :x : at dot signs public dash key :x : at dot key. And if I execute this now, ta-da! I have just verified that this thing here originated from the person owning the private key associated with this public key. So I've verified the signature of the message, and if there was something wrong, if I, for instance, change this 1 to L, then an exception, actually it was an L, I think. Let's change it to 1. 4. Yes, I'm modifying the hash of the key lookup. If I change further back here, boom, signature mismatch. So now the signature no longer matches the RSA signature verification process, throws an exception because the signature has been tampered with and or the payload has been tampered with. And the first 32 bytes here, of course, is just a reference to the public key to allow the server to look up which public key to use. However, I'm manually pasting in the public key here. So the first 32 bytes here is basically useless for this particular invocation. So this allows me to actually keep a ledger, if you want to, of invocations. If I now go back and I invoke another request here, evaluator, okay, load, magic, idempotent, and I write some dash unique ID here, I execute it, have a success. I refresh. I see one additional invocation here performed by the same user, the guy who owns the email address of thomas@servergardens.com. More importantly, if I try to replay the same request here with the same request ID, ta-da, invocation to cryptographically secure the HTTP REST endpoint was not successful. And on the server side of things, of course, a log entry is created showing you why. Request with the ID of some unique ID here has been previously evaluated on the server. And of course, the request ID is a part of the original payload. So the request ID is also cryptographically signed. If I append -2 here now and I evaluate it, everything is kosher. And we now have one additional request, 3 requests here from this particular client. So this creates, you might say, arguably a financial transaction system, allowing me to legally guarantee that this request originated from this client, period, end of debate. And it could be used for instance, things such as, bank transactions or, crypto wallet, transactions or purchasing things, etc., etc. I mean, I haven't even vaguely imagined more than 0.0001% of the use cases. But obviously, I mean, the slam dunk use case is to simply implement it as, a bank. Having the private key effectively being your password, and then, having requests containing text such as, deduct from my bank account, insert into person B's bank account, etc. So anyway, that was it. Yet again, there's a link in the description of this YouTube video to where you can download Magic. Please be a little bit patient about this. It is fairly experimental at the moment, I have to admit. And there might be some bugs, among other things. I haven't tested it at all in SQL Server, Microsoft SQL Server, but I think it will probably work. Anyways, thank you for watching. Have a nice day.